Hey GED students, it's GED question of the daytime. Looks like we've got a word problem. Let's take a look. Marin runs a charity that distributes backpacks full of school supplies to inner city children. Well, that's nice of Marin, but it's still not any math yet. Let's keep reading. She wants, just proof is in the pudding that I am bad at grammar, although I am decent at math. She wants to put a pencil box in each backpack this year. She has 108 pencils, 306 pink erasers, 48 ballpoint pens, and 60 highlighters. What is the maximum number of identical pencil boxes she can assemble? So here's Marin. She's got all these supplies, and here's the key word. We want to get the maximum number. What is the maximum number? Would you agree with me that another way to say maximum is greatest? So the greatest number of identical pencil boxes. That's another key. We want identical pencil boxes. When you think identical, you should be thinking same size groups. It should kind of put you in the mind of multiplication, division kind of thing going on. Now, I want the maximum number of identical same-sized groups, the maximum number of times I could divide. And if you look at this, I have a bunch of different things I need to divide up. The pencils, the erasers, the pens, the highlighters. I'm going to divide them all up, and I want to divide them into the greatest number of groups possible. What am I talking about? This is a math concept known as greatest common factor. I may never have used the words greatest common factor here, but I basically asked you, what's the biggest number that can divide all these numbers? What's the greatest common factor? So we've got a bunch of numbers here. Looks really scary to do a GCF problem with, but I'll just remind you of my fabulous little GCF trick where don't worry if you don't know the GCF right off the bat. We can build it. And how I'm going to do that is by writing all these numbers, and I wrote 108 so messy, I want to write it again, in a kind of like upside down division box. Now, I got to tell you the truth, it's not really the box that matters. That's just helping me organize my work. What matters is that I think of any factor I know of that divides all these numbers. So maybe you're looking at these numbers and you're like, Kate, I have no idea. These numbers are really, really big. I don't know anything they have in common. At least I should hope that you could notice that all these numbers, even though they're really big, are all even. If numbers are even, that means they're all divisible by 2. And so at least I could divide out a 2. Let's give it a try. And if you know sight division, which is what I'm about to use here, your division will be much easier. If you don't know sight division, I suggest you go check out a video. It is the coolest thing. So let's see. 2 goes into 10 5 times. 2 goes into 8 4 times. 2 goes into 3 1 time. Remainder 1. 2 goes into 16 8 times. 2 goes into 2 twice. 2 goes into 8 4 times. 2 goes into 6 3 times. 2 goes into 0 0 times. So I have all these numbers left after I divide out the common factor of 2. Now notice I still have some numbers left. You should still be asking yourself, is there anything these numbers have in common? Now one thing I noticed is that all these numbers are on the 6 times tables because I know my 6 times tables. What if you don't know your 6 times tables? Well, then you can still keep pulling out one factor at a time, like pulling out another 2. But I know my 6 times tables, so I'll pull out a 6. So 54 divided by 6 is 9. And 18 divided by 6 is 3. 24 divided by 6 is 4. And 30 divided by 6 is 5. Now again, I'm looking at my row that I have here and asking myself, is there anything else these numbers have in common? Well, 9 is divisible by 3, as is 3, but I can't find a 3 inside of 4 or 5. In fact, there's nothing that divides all these numbers that's any bigger than 1. And I always joke, whether you're reducing fractions or finding the greatest common factor, once you get to 1, you're done. And so I am done here. I found 2 factors inside of these numbers. I found a 2 and I found a 6. If I want the greatest common factor, I've got to multiply these numbers back together. So 2 times 6 is 12. So even if you don't know your 12 times tables, you can still find a GCF of 12 by building the 12 one factor at a time. All right, if you have any questions about this or any other GED topic, be sure to drop it in the comments and I'll do my very best to answer it.